Today we're going to talk about how to find the area of regular polygons inscribed in circles. First of all, we need to remember what regular polygons are. Regular polygons are any polygon that has the same, that their sides are the same length and they all have the same interior angles. So like a square would be a regular polygon, or an equilateral triangle. So to know how to do these, you have to understand a few things. Just like the center of a circle is called the center point, we also have the center of the polygon, which is also the center point of the circle when it's inscribed. So any line that's coming out of it, like here, would be the radii. Okay, so the radius of the polygon is the radius of the inscribed circle. So you could actually draw a radius or radii to every point where it touches the circle. Now, there's a new word you're going to need to know. It's called the apothem. Now, what the apothem is it is a line segment from the center of a regular polygon, or the center point, to the midpoint of a side. So I've kind of drew one over in here. So this blue line is the apothem. Now, if we were just to look at the triangle made by the two radii, we could even call that an altitude. It splits that angle right in half and forms a 90-degree angle. Okay, but this is an apothem, and it's very important for finding the area of regular polygons. The other thing you need to know is the central angle of regular polygons. And these are angles formed by two radii drawn to consecutive vertices of the polygon. Or in other words, this right up in here, this angle that's going to be right here. That would be the central one. And to find it, all we do is we take 360 and divide it by the number of sides. So in this case here we have 1, 2, 3, 4, 5, 6 sides. So to find the central angle, we'd go 360 divided by 6, which would be 60 degrees, would be the central angle. Here's a quick little exercise to help us find the angles we need to be able to find the areas of regular polygons. So in this diagram, it wants us to find the measures of three different angles. The first one is AFB, which is the big one. And to do that, we have to find the central angle. So we'd go 360 divided by the number of sides. In this case, since a pentagon has 5 sides, we divide 360 by 5, we get 72. And that is the central angle. Now it wants us to find let me change colors here, AFG. Okay, so this angle right here. Now to find that, we know that's an angle bisector. And so all we do is go 72 divided by 2, and we know that that angle equals 36 degrees. And the last one it wants us to find is the angle GAF. And to find that, the easiest way to do is go 180 minus 90 minus 36. Because we know the other two angles here and here, it's really easy to find this angle. And 180 minus 90 minus 36 is 54 degrees. Now let's do another example quickly. This one wants us to identify the radius. Again, that's going to be from the center point to wherever the regular polygon touches the circle. And there's going to be two of them drawn here, so PY, segment PY and segment PX are the two radius. And apothem is going to be PQ, or the line that goes from the center of the circle or polygon to the mid-segment, the mid-segment of a side. And what else do we want us to find? Oh, the center of the polygon, which is P, point P. Okay? Oh, let's find the central angle. So again, the central angle, we go 360 divided by the number of sides, which is 4. 360 divided by 4 is 90 degrees. Okay, so our central angle is 90 degrees, which is what the next question wants us to find. The measure of angle XPY is 90 degrees. That's the center angle. Now it wants us to find XPQ. Okay, so angle XPQ is going to be half of XPY, so it's going to equal 45 degrees. That kind of tells me something. It's probably going to want us to find PXQ. Yes, so next it wants PXQ right here. So measure of angle PXQ is going to equal 180 minus 90 minus 45, which equals 45. Alright, now let's talk about how we actually find the area of regular polygons. So the area of regular polygons is 1/2 times the apothem times the number of sides times the side length. Okay, make sure you put this in your notes somewhere. You need this. Actually, it's going to change in just a minute a little bit. Okay. So you could also change that to the 1/2 apothem times the perimeter, because really the perimeter is just the side length times the number of sides. Okay. So to be able to find the area of a regular triangle, you have to find the apothem and you have to find the perimeter. And those are kind of the tricky part. So let's look at an example here. So here is a inscribed regular polygon. First thing I'm going to do is find out how many sides. And if you count this one, you find that you have 9 sides. Okay. They have a center point. The center point is R. We know the radius is 4, so RQ is 4. So I'm kind of going to draw a little line to RP. We know that's also 4. Now the first thing you're going to want to do is find the central angle. So the central angle is going to be 360. I'll put that down here. 360 divided by 9, which equals 40. That's our central angle. Okay. Now we took kind of a screenshot over here, and I already broke it up for you. Okay, so here's this part down here, so we can look at it a little closer. Okay, so we know that MRP is 20 degrees because it's half of 40. But to be able to find the perimeter and the apothem, we need to find the lengths of, first of all, the apothem, or RM, and then we need the side lengths, which is PQ. So let's start with the apothem. So to be able to find this, we're going to have to use a trig ratio. And because we know that this angle is 20, and we know there's a hypotenuse, we don't know what this side is. But that would be the adjacent to 20, so I'm going to use the cosine. So how I would set that up, so I'd say the cosine of 20 equals the adjacent, which we don't know, so I'm going to put x, over 4. 4 is the hypotenuse. And then we're just going to solve for x. And that'll give us the side. So to do that, I'm going to times 4 by both sides. And I go that 4 cosine of 20 equals x. All I do is plug that in my calculator. And when I do that, I get, let's see, 3.76. So x equals, or the apothem equals 3.76. That's all we have to do for that one. Now for the perimeter, we're going to have to find what this length is here. And I'm again going to use a trig ratio. And since it's the opposite side, I'm going to use the sine. So I know the sine of 20 equals x over 4. Not a very good 20. And again, I'm going to times both sides by 4 to solve for x. And I'm going to plug it in my calculator. And once I plug it in my calculator, I get 1.37. But that's just MP equals 1.37. Okay, but I need QP, so I'm going to have to times that by 2. And I get 2.74. And that's just one side. To get the perimeter from there, I'm going to have to times that by 9. And when I times that by 9, I get 24.66. And that is the perimeter. So now we know the perimeter and the apothem, so we can find the area. Again, the area of regular polygons equals 1/2 apothem times the perimeter. Okay? So we'll just plug these numbers we already got in. So we get 1/2 times 3.76 times 24.66. And we plug that in our calculator. And our answer becomes 46.36 units squared. And it didn't give us our units, so we'll just leave it as 46.36. Alright, let's do one more example. Okay, in this one it wants to find the perimeter and the area of the regular polygon. So this polygon is a triangle, so it has 3 sides. Remember, we're going to have to find the length of the apothem, and then we have to find the perimeter, obviously. Now this gives us the area, the apothem. So we already know the apothem, or A, equals, we'll do a small a, 5. To get the perimeter, we're going to have to find the central angle, which is 360 divided by 3, which gives us 120. So this angle right here, all 3 of those angles are 120 degrees. And then we'll have to divide that by 2 to get this angle, which is 60. So basically we have a triangle here that is a 60 degree, and we know this is 5. Now this is a special triangle. A 60, 30, 90 is a special triangle, so we don't even have to use a trig ratio on this one. We know that because this is the short side, the long side of a 60, 30, 90 degree triangle is 5 times the square root of 3. And when we put that to decimal, we get, let me plug that in real quick, 8.66. Now to get that full length, my phone keeps going off, I apologize. To get my full length, I'm going to have to times that by 2. So we found this length right here. Now to get this whole side, we're going to have to times it by 2, which gives us 17.32 is the whole side. Now there's 3 sides, we'll times it by 3 to get the perimeter, and the perimeter equals 51.96. That's the perimeter. So there's one of our answers. Now it wants us to find the area. So again, the area is 1/2 times the apothem times perimeter. So we'll put 1/2 times the apothem, which is 5. It gave us that. And the perimeter is 51.96. Once you plug that into your calculator, my answer is 129.9 units squared, whatever unit they are. So that would be the area. And those would be your 2 answers.